This is an example of using the 9211A sampling oscilloscope to measure jitter on a high-speed serial telecoms signal. So here I have connected to channel 1 a STM4 signal clocking at 622 MHz. Though there are three ways of measuring jitter on this signal with this particular instrument. We can do it manually using markers. We can turn on the X markers, and then you would position that on either side of the crossing of the signal, and we could directly measure the peak-to-peak jitter of the signal. So this particular signal, it is around 80 picoseconds. A more accurate way of doing it is to use measurements menus. So I'll turn off the markers, and here I'm going to select the eye diagram measurements, and this is actually a non-return to zero encoded signal. So I'll select that, and again we've got X and Y measurements. So I'm going to want to measure time jitter, so I'm going to select an X measurement and select peak-to-peak jitter. So here we can see it's looking for the crossing point. We can actually use the define parameters, and it can show us where the measurements are being made. And turn on the view parameters. So here we can see it's selected the first eye, the left and right crossing, and is making a direct measurement. So it's again measuring 50 picoseconds peak-to-peak jitter. A third method of doing this measurement is using histogram. So I'll turn off the automatic measurement here and now select the histogram menu, and again we can do vertical, so we can look at amplitude jitter, or in this particular case we want to select horizontal jitter, and then we can position the measurement box again on the crossing, and down here we will see again a peak-to-peak measurement of 40 picoseconds peak to peak, and typically the histogram is the most accurate way to measure jitter. So three methods to measure your jitter: manually with the cursors, automatic measurements, and the histogram technique.